Hey guys, it's Madison. Today I'm going to be teaching you about graphing absolute value. Absolute value is the distance of a number from zero. As you can see the graphs on the screen, those are called the parent functions, which we compare all other functions to in this unit. The function always is y equals the absolute value of x. Rules. Whenever you graph an absolute value function, it should be a symmetrical v-shape. When the question asks how many units the graph transformed from the mother function, it means how many units away did the second function move from the mother function. It can translate up, down, left, and right. As the coefficient of a function increases, the graph becomes steeper or more narrow. As the coefficient of a function decreases, the graph becomes flatter. Lastly, here's a translation key so you know which functions translate which way. Thank you for watching.
This is Chetkof, and I'm going to show you how to graph an absolute value function. In this case, as you can see, y equals x plus 6 in the absolute value, and y equals x in the absolute value minus 6. Okay, so here I solved what I marked as the y1 value, and I ended up using the values -8, -7, -6, -5, and -4 as the x values. And that's because you should have on your table, you should have the value where your graph will reflect. You want that to be the middle value, and in that case this is the -6 for the x value, and the y value for that is 0. And on your table you're going to want to go 2 up and 2 down on the values. And I graphed it, as you can see there. You just put the points that are revealed on the table, and then you'll graph it and put the arrows, and don't forget to label the graph. Okay, as you can see here, now I solved for the y2 function, and this time the x values were -2, -1, 0, 1, and 2, because 0 was the middle value that reflected over the axis, the y-axis. And I used the same strategy. You do it the same way. You could either do the same thing in the calculator or input values into x and solve by your mind. And I graphed the same way, put the points down, the x point, y point, same way you always do, and that's how you solve graphing absolute values.
This is Hunter, and we're doing step functions. Step functions are a graph that resembles a set of stair steps as it increases or decreases abruptly from one constant value to another. If the symbol is less than or greater than, the dot is open. If the symbol is less than or equal to or greater than or equal to, then the dot on the graph is closed.
My name is Nastro, and I'm going to be showing you an example of a step function. The first thing you should do when labeling a step function is to start by labeling your axes. Next, you will need to figure out whether you'll be placing an open or closed circle at the beginning or end of your step function. Since for the first step in your step function, -2 is less than or equal to x, you'll be using a closed circle for the beginning of your step in your step function. Since x is less than 1, you'll be using an open circle for the end of the first step in your step function. Remember that each step in this function will begin with a closed circle and then end with an open circle. Next, we are going to be graphing the steps of the step function. Since for the first step, g of x is equal to -1, and x is greater than or equal to -2, your first spot that you'll put a closed circle over will be -1, -2. Since x is less than 1, the next point that you'll be putting an open circle over is -1, 1. Next, you'll be using a line to connect the points to make the first step of your step function. Repeat this process for all the other steps in the function. In the end, your step function should have looked something like this. Good job!